Hello my dear students, today we are in lecture number 28 of chapter 2, same unit electrostatics. I am B.S. Pandey. My dear student, today we will do the numerical questions and plate problem, okay? Dielectric and plates problem. Dielectric and plates problem. Before starting that particular topic, I'm just discussing over here a very important numerical question that has been asked in CBSC, okay, 2004. Now, so this was the question in CBSC. You are given two capacitor, say X and Y. It is connected by a battery of 12 volt. I think 12 volt was there. X and Y. If you want to write the complete question, student, you can write X and Y are the two parallel plate capacitor having the same area. Remember, same area of plates and the same separation between the plates. X has air. Here, medium is air. Okay, medium is air. X has air between the plates, and the second capacitor Y contains a dielectric. Remember, of dielectric constant 5. Okay, it contains dielectric or dielectric constant 5. Now you have to find two things. One, to find calculate potential difference between X and Y. Okay, that is the potential across X and Y. Potential across capacitor X and Y. The second, what is the ratio of electrostatic energy stored in X and Y? If energy stored in X as Ux and across Y it is Uy, then you have to find the ratio. Okay, so this was the question. Now, if you can solve, pause your video and try to solve this question. This is a very important question, my dear student. Okay, try to solve by yourself. Now, look at here for the solution. First, you have to find the ratio for capacitance, because capacitance, suppose it is the capacitance C, then what will be the capacitance for Y? For Y, the capacitance will be 5 times C. Am I correct? Yes. As we have studied, if dielectric is introduced, then capacitance increase by the K times. Okay. Now, so if it is C, then it will be 5C. Why 5? Dielectric is 5. The dielectric constant is 5. Then the capacitance will be 5 times C. Okay. Now, it is already connected in series. In series, we know that in series, what will happen? Charge remain constant. So Q equals to C into V. The total charge here, that is, suppose the potential is V1 over here. So the C1 V1 is equals to C2 V2. Am I right? That is C1 by C2. We can write here the V2 by V1. Okay. So the C1 by C2. C1, it means Cx. It is C by C2. How much? It is 5C equals to V2 by V1. Now, we are having a relation between V1 and V2. That is V1 and V2. It is V1 is equals to 5 times V2. Note down. This is the one relation. Okay. Now, you can see here the potential we have taken V1 and V2, but this total potential how much? It is given 12 volt. So V1 plus V2 it is how much? 12 volt. And V1 is 5V2 plus V2 and it is 12 volt. It means V2 is, it is the 6, 12 by 6 it is the 2. So it is 2 volt. Are you getting my dear student? Now if V2 you have calculated, you can find the V1 also. Here the V1 will be, put the value of V2 over here. So sorry, here. So the V1 will be how much? It is 5 times V2, that is 10 volt. Now you have to find the ratio of, here already you have find potential across each. The first question you have solved. Now the second one, to find the ratio of potential energy Ux, it is half C1 and V1 square, half CV square, we know that, and Uy, it is half C2 and V2 square, but Ux by Uy you can write as half C. V1 was how much? So the V1 is 10 square divided by half C2 was how much? It is 5C into V square, how much V2 was? So the V2 was 2 volt. So the 2 square, as it is 10 square. Now calculation, C will be cancelled out, half will be cancelled out. So it is 1 by 5 into 100 divided by 4. Okay, 5 times. So 5 is to 1 will be the correct answer. Okay, my dear students, so the Ux by U1. This was not a very tricky question, but yes, it was of good level. It was asked in your CBSE examination. Such type of question it will be asked. I have been given in assignment also. Let me drop this one. Now we'll move for the next topic, and it is the plates problem. So my dear student, in the next we are going to find here the dielectric and plates problem. Okay, dielectric and plates problem. So my dear student, here suppose if we have a capacitor of capacitance C, the plate area A, separation is D, what will the capacitance? C will be epsilon naught A by D. After inserting a dielectric of relative permittivity, it is K, that is the dielectric constant, what will be the new capacitance in presence of dielectric? It will be K times epsilon naught A by D. Okay, no doubt. Now we will solve few questions. Here the first example, this is the parallel plate capacitor and we are putting here two dielectrics. Okay, two dielectrics, divide by the half, here the K1 and here the K2, d by 2, plate area is A. Now what will be the capacitance between X and Y? As we have practice over the number of capacitor, okay, if dielectric is filled, the one dielectric over here and another dielectric over here we have filled, we had practice how many capacitor you can see here, the two capacitor you can see. Student, how you have to proceed, just try to learn. Whenever you look the capacitance boundary, sorry, the dielectric boundary, cut the capacitor or the dielectric to separate. From here the dielectric are changing, we will cut from this one and we will have the capacitor now in this way. The terminals and this is the boundary of dielectric. Now this is the separation d by 2 and this is also d by 2, but these two boundary were in contact, so make them in contact with a conductor. Now this is one capacitor with dielectric K1 and this is with K2. Okay, now plate area remains same. Plate area remains same because we have been cut out in this way, so the plate area remains same. Suppose it is C1 and it is C2. Now you can see these two capacitor connected in series, so the C equivalent will be how much in series? It is C1 C2 by C1 plus C2. If you can write the value of C1 and C2, then you can put over here in this one to find the equivalent capacitance. And C1 is how much? Epsilon naught A by D, and D is what? D by 2 times capacitance, sorry, dielectric, it is K1, and C2 is K2 epsilon naught A by D. How much? This one, it is 2 K1 epsilon naught A by D, and it is C2 is 2 K2 epsilon naught A by D. Okay, my dear student, you can put this 2 to find the equivalent capacitance. Actually, the aim of this question was to just explain how to study the capacitor, two capacitor with dielectric. Now, another question I'm giving you. This will be your classwork first. Then after I'll solve this question. Okay, you will pause the video and solve this question, my dear student. Okay, so this is your classwork. Now this capacitor is filled with dielectric and this is air. Okay, d by 2 filled with dielectric and d by 2 air. Here the dielectric constant K, plate area A, and the total separation is D. You have to find the equivalent capacitance. Okay, try to solve. Now look at here. Suppose this is C1 and this is C2 and both are in parallel, so the C equivalent will be C1 C2 by C1 plus C2. So what will be the C1? C1 will be, since in the first capacitor we have joined, here we have filled our dielectric, so it will be K times, okay, K times epsilon naught A by D, and C2 it is epsilon naught A by D by 2, since the K will be 1 for air. Now you can put the value of C1 and C2 in this formula to find the answer. Now this is your homework, the first one. If the dielectric is placed, okay, let me solve this question as a classwork, then I'll give you the homework. The two questions I will solve in class and then after I will give you few questions for homework. Now other dielectrics are filled in this way. This is the K and this is 2K. plate area, total area, it is A, total separation, it is D. You have to find the equivalent capacitance. Now, my dear student, we will divide the capacitance in this way. So it looks like this one. The one, it is filled with K1, that is K, and another filled with 2K. But both the plates were in contact. So make the contact with a conductor. And this is the terminal, one terminal and another terminal. The dielectrics are filled in this one and this one. You can see this capacitor are in parallel. So the C equivalent will be C1 plus C2. Now the value of C1 and C2. C1. Since this plate has been cut out from here and the plate area was A, if it is cut equally, then it will be A by 2 and this is also A by 2, but the separation is not going to be changed, so the separation remains same. It is D and D. Now the C1 epsilon naught, and the dielectric is K, so the K epsilon naught A, but A is changed, A by 2 by D is not going to be changed, C1 and C2. So the C2 is K, which is 2K epsilon naught A by D. Now you can put the value of C1 and C2 in this equation to find the answer, my dear student. Now the next question I'm giving you. And this one is in this way. The terminal action Y. K, here K, here 2K. Okay. Dielectrics are filled. You have to find the capacitance. First, if you can solve this question, try to solve. Otherwise, you should at least cut the capacitor in proper way and connect with the conductor, because this is all in connection. Now we are cutting. First we'll cut from here. We'll have a capacitance with the dielectric K. Okay. Plate area A, separation D. What will be the plate area? If cut out with the half, the plate area will be half, A by 2. Now the below one is to be cut in two equal part. So we are cutting here in two equal part, but these two were connected and these two were connected. So this two should be connected and this two should be also connected. Now this is the final terminal X and Y. This is K and this is 2K. How many capacitors are there? 1, 2 and 3. For this capacitor, my students, for this capacitor, you can write, suppose it is C1, C2 and C3. C1, C2 and C3. Okay. What will the equivalent capacitance? Here these two are connected in series. So for this two, we can write C2, C3 divided by C2 plus C3. And now these two are in parallel. So plus C1. This is the C equivalent. Remember, this is looks like lengthy, but this is very easy. While you will put the value, this entire calculation will be very easy. So the C equivalent C1 plus C2 C3 by C2 plus C3. Now the C1 C2 and C3. If you can write the C1 C2 C3, then that will be very easy. So the C1, it is K epsilon naught A by 2 by D. Separation not going to be changed over here. If it is D, then D. Now here plate area and separation both will have. Okay. So the C2 K epsilon naught A by 2 by D, which is D by 2. Now C3 K, that is 2K epsilon naught A by 2 by separation D by 2. Now you are having the value C1, C2, C3. Remember, you should be very smart while calculation. You don't have to put this all the values. You have to simplify this one. For example, I'm telling you this K epsilon naught A by D, suppose C. Okay, then what will be C by 2? K epsilon naught A by D, suppose as C, then it will be the C by 2. Okay, this 2 will be in denominator, then it will be C by 2, and this will be how much? So this 2 will be cancelled out, this is C, and this 2 will be cancelled out, this is 2C. Okay, this will be C, this will be 2C, and this is C by 2. Now you can put the values, and finally you will put at the place of C K epsilon naught A by D. Okay, my dear students, in this way you have to be very smart while calculation. So these are the question that may be asked for the dielectric. Okay, now we will move for the plates problem. One question I'm giving you, my dear students, homework, if you can solve a little bit conceptual. The two plates, but the dielectric is filled in this way, X and Y. Dielectric is filled in this way. If you can solve, I'll be very happy. K1 and K2. Dielectric is filled in this way. First dielectric, and this is the second dielectric. The plate area A, separation D, and diagonally the two, okay, the dielectrics have been changed. This is your homework. If you can solve, then you should show me after solving this question, my dear students. Now we'll move for the plate problem. This was the simple dielectric problem. We will solve few more questions also on the dielectric. Otherwise, I'll give you in group the question for the dielectric. That is very important in board examination. Now, the plate problem. The simple plate problem. Today we are going to solve. Here, the first one, the plate problem. This two is being connected by a conductor and positively charged, and the one plate, it is negatively charged. You have to find, remember, between all the plates the separation will remain same, D, and the plate area A. A will be the plate area and D will be the separation. Okay, what will be the equivalent capacitance? Remember, I'm just giving you the training to solve question. As we have studied already to find the number of capacitance, today you will study what combinations are there in this plate, in between this plate. So first you have to give the nature. If it is positive, positive, up and down. If it is negative, negative, up and down. Okay, now the second, you have to give numbering 1, 2, 3. Okay, now start making the capacitor from above. Whether the 1 plus making any capacitor from above one, answer is no. So the 1 plus making with the 1 minus, sorry, 2 minus. So the 1 plus 1, and it making with the minus 2. Do you have another minus 2? Yes. So write minus right side and plus left side. So the minus 2, and it is making with the 3. So it is plus 3. Do you have another? No. Now try to find out the connections. Plus 1 is connected with plus 3. So the plus 1 is connected with plus 3, and minus 2, both minus 2 are already connected. So minus 2 are already connected. Now find the terminal. One terminal, that is the X, from these two connection, that is this one, and another terminal from this two one. You can see very easily these two are connected in parallel. Now the capacitance, if it is C and it is also C, then C equivalent will be in parallel to C. Okay, now the next question I'm giving you. This is our classwork. my dear students. Let me connect this one as okay. This is as negative and this is as positive. Now, what will be the equivalent capacitance? If you can solve, try to find out the answer. Okay. Now I'm solving. First, we have to put the polarity. Here minus, up and down. Here plus, up and down. Now, if it is plus, then by induction it will be minus, and since it was neutral, it will be plus. Here minus, due to induction, it will be plus, and above it was neutral, so it will be. Now, plate numbering 1, 2, 3, and 4. Okay. Now, plus 1 here making a capacitor with minus 2. Now minus, this is the 2 has another minus, and this is making capacitor with plus 3. Plus 3 has another, and it is making capacitance with minus 4. Now the connections will decide the series and parallel combination. So my dear student, here 1 and 4 is connected. You can see 1 and 4 is connected. 1 and 4. So you have to connect this 1 and 4. Now both the 2 is already connected. Both the 3 already connected. Now terminal. Try to find out the terminal. So 2 has one terminal and 3 has another terminal. Now totally it will depend on your IQ if you are able to see the combination by the way I am just changing this one. Remember, this is the flexible circuit. Could you take this capacitor in this direction? Yes. Could you take this capacitor in this direction? Look at here carefully. Here the one capacitor, this one. I am taking this capacitor here. Here the one capacitor, 1. Okay, I am writing here the C1, C2 and C3. So I have taken here the C1 and this C1. C1 has the one terminal. It is going to meet with here with C2, but C1 has another terminal which is connected with which one? It is C3. It is connected with C3 and C3 another terminal. C3 another terminal. C3 this is going to connect with the C3 and C3 another terminal going to meet with the C2. It is C2. Okay, look at here this C2 and C2 another terminal, it is going with to C1, so it is going with C1. Now the terminal, you can see the terminal between C1 and C2, so here the C1 and C2, the one terminal, and between C2 and C3 the another terminal, C2 and C3 the another terminal. You can see easily this is 2 are in parallel and this one is in series and this one in parallel. If you are not able to understand, repeat this video again and again and try to understand. Now the answer will be these 2 in series, C1 C3 by C1 plus C3 plus C2, and this is very simple. C1 C2 C3 you can write. If all the specifications are same, then C. So this will be C by 2 plus C. So the answer is 3C by 2. I'm giving you few questions on this plate problem. Okay, if students you will be not able to understand properly, then you can give in comment. I'll repeat this class and I will solve. by myself the number of question, okay, then you will be able to solve. But I'm giving you the homework. You will try to solve this question by yourself. This is negatively charged, this is positively connected. You have to find the capacitance, the second one. Okay, if you will able to find out the number of capacitor and proper numbering, then I hope that you will be able to solve this one. This is positively and this is negatively. Okay, now the third one. Positive and negative. So you have to find the capacitance for each three plates problem, my dear student. Okay, so these are the plates problem. In next class we will study few more interesting question, and then we will come to the next segment of this particular unit. Thank you, students.